This lesson, lesson 79, is a kind of continuation of lesson 72 and lesson 75. Lesson 72, or 71.
What are you videoing?
I think it's 72, yes.
Okay.
We factored trinomials like this, x squared plus 5x plus 6, right? Mm-hmm. And we said that factors as x plus 3 times x plus 2. So just straight up a equals 1. Now in lesson 75, which we're quizzing on tomorrow, we had things like 3x squared plus 11x plus 8, where the first term is not 1. Today we're going to add a GCF into the mix. So still dealing with trinomials, but we're going to put a GCF factor into the mix. Now, just a reminder, factoring out a GCF is, like 2ax squared minus 8a minus 8ax. What would the GCF be to factor out of this? 2ax would leave us with x minus 4. Right? Yes, but we're going to be trinomials. And then what's left over, y'all listen, what's left over inside when we take out the GCF will be a problem like lesson 71 or 75. Okay, so we're just adding an extra step on the front end of things. I really don't like the way Saxon introduces the trinomials in 71, 2, and 75, and then GCF is last, because the last thing they're showing you is the first thing you have to do. Okay, so now we're going back and we're adding a little wrinkle to everything we've done first. You've got to check for a GCF first in order to factor a polynomial completely. All right, so I think it's a little bit out of order from the way I teach it. And when we do our factoring review at the end of the year, we're going to do it as a unit the way you're going to see it in Algebra 2. Okay? All right, so here's an example. X to the fourth plus 5x cubed plus 6x squared. Now, this is not a quadratic expression. It's not quadratic-like. All right, it's a trinomial. It's a fourth degree trinomial. And in order to factor this, we first have to take out a GCF of x squared. So when we take out the x squared, we are left with x squared plus 5x plus 6, which we have to see if that trinomial can be factored further. Okay? And this actually looks exactly like the one that we just factored a moment ago as an example, right? What are the factors of 6 that add up to be 5?
2 and 3.
So we can factor that as x plus 2 times x plus 3.
Oh.
So this is the complete factorization of that polynomial that we started with.
You got to think about it.
Yeah. It's a process. It's really a checklist. And all of our factoring methods, and when we do our factoring review as a whole, you're going to have a checklist for factoring. You check for this first, then you check for this first, then you check for this. Okay, once you've checked everything, you're done. But the first thing on every list is GCF. Okay, so let's have a look at this one. What is our GCF for this trinomial? 4x is correct. So that will give us x squared minus x minus 20.
Is that going to be factored?
I think it probably can. Are there any factors of negative 20 that add up to be negative 1? Factors here that add up to this.
4 and 5. Negative 5 and 4.
Negative 5 and positive 4 would give us negative 5x plus 4x, right? Negative 5x plus 4x is equal to negative 1x, and negative 5 times 4 is negative 20, and 4x cubed minus 4x squared minus 80x takes us all the way back up to our original one. So you have to be careful at each step to kind of make sure that you're doing it correctly, but that's the complete factored answer. Okay? Now, not really. Now, when we're solving these equations, when you're solving these equations in higher order, remember how many solutions does 4x cubed minus 4x squared minus 80x equals 0 have? It's a third degree equation that has 3 solutions. Those 3 solutions come from these 3 factors. The 3 solutions are 0, 5, negative 4. Okay, that's just a preview of how you'll apply this skill of factoring later on. Okay, all right. What about this one? Now we've alluded to this in some of our earlier factoring lessons. It's kind of awkward to factor something that has a negative leading coefficient. So we're not going to change it. We're not allowed to change it. No, you can't multiply through it because this is not an equation. Remember, we're allowed to multiply equations in changing all the signs. We're not allowed to multiply this by anything except positive 1, which is not going to change anything. Okay? So what we're going to have to do is factor out the negative, or you could factor out a negative 1, however you want to see it. But if we factor out a negative, that makes the first term positive, the second term negative, and the third term negative. And now we have something that's a little less awkward to factor. Right? Because think about it. If you tried to factor this, how would you do that? Are there any factors of 56 that add up to be positive 1? No, they're not, but you got to remember that this negative 1 has to go over there and multiply by that 56. Are there any factors of negative 56 that add up to be positive 1? And there are. Okay? So this is awkward. It's very awkward. It's not as awkward once you factor out the negative sign and make your leading coefficient positive. Now, are there any factors of negative 56 that add up to be negative 1? We need it to be negative 1, which means the largest factor has to be positive.
Why does it have to be negative 1?
Because negative x.
Oh, yeah.
You don't change it back to the first one?
No, this changes it.
That's
Oh,
your.
yeah.
That's the GCF.
Oh, so that's it.
Wait, if you
Oh,
had,
okay.
if you had like negative 7 and positive 8, would that be wrong?
Yes.
If this is here, yes, it would be wrong. Where would you get that from, though, Mary Helen?
I don't know.
That's what everybody said initially. And 9 times out of 10, as a student, if you say something, what are you going to do? You're going to write it. Yeah, and you miss the problem. And so I'm not sure where the disconnect is coming from there. We need the factors of negative 56 that add up to be negative 1. So the largest factor has to be negative. Okay, so just kind of remind yourself of that. This negative sign is in charge of changing that negative 1 right there back to positive 1 that we started with. And so that negative sign has to be a part of your answer. Okay, what about this one?
You have to factor out a negative again?
You have to factor out a GCF and a negative. Yeah, so you got to be careful with this one. Yeah, if your leading coefficient is not negative, it's a good idea to factor out if your leading coefficient is negative, it's a great idea to factor out the negatives. It's just awkward to factor with a leading coefficient that's negative. It can be done, it's just awkward. Now, when we start turning these into equations a little bit later, boom, then you can change all the signs.
Yeah.
Right? Because it's okay to multiply both sides by -1. It's not okay to just multiply any expression by -1. You can't do that. It changes it. So what will we factor out? -3x times.
X squared minus 2.
Be careful.
Minus 2.
It's
Oh, wait,
plus
yeah, it's
2x.
Because negative.
All right, we're factoring out a negative, so that's going to change the signs of all the terms. Minus
Minus 24.
24.
Oh.
That's an odd looking 2.
It's beautiful.
All right, now are there any factors of -24 that add up to be positive 2?
-6 and 4. No. I mean,
You did it
-4 and
again.
6. I wrote down the right thing. I just put.
Okay, careful. Positive 6 and -4 would give us 6x and -4x, which is 2x. That's -24, and that's x squared, and this -3x would distribute times all that to take us back to where we started. So it checks out.
So when you factor out a negative, it changes all the signs.
That's correct. But we're not changing all the signs. It's still, if you multiply this all back together, you get what you started with. Changes the signs inside the parentheses.
Yeah.
The signs are still the same as the original problem. All right? So it's just a little awkward to factor with a leading coefficient that's negative. So take out the negative at least, if not the GCF. All right? Try this one on your own. Let me pause. So we get bx squared times x plus 5 times x plus 4. That's correct. Now, the intermediate step would be factor out the bx squared, and that leaves us with x squared plus 9x plus 20. And the factors of 20 that add up to be 9 are positive 5 and positive 4. So we are in good shape. All right? Last example. Okay? What do we have? Okay, sorry, I'll pause. Okay, so when we take out 5bx, we're left with x squared plus x minus 12. And then the resulting trinomial, now keep in mind that this resulting trinomial may not always be factorable. Sometimes the only thing you can do is take out the GCF and then you're done. That doesn't mean we haven't factored, because we have, right? If we factor out a GCF, we have factored this expression. But in this case, as in all the problems that we worked today, there are factors of -12 that add up to positive 1, and those two factors are 4 and -3. All right?
Gotcha.
So that's it. We're going to skip that one and that one. And there's your homework.
We have more than 20 minutes to do homework.
We do. Isn't that great?
I've already done this lesson.